Hey guys, Mr. Marone here. Welcome back after our long break for proof of algebra and geometry essentials. So now we're going to move into lines and transversals. So you can follow along with these notes in your notes packet. We're going to first look at parallel lines, parallel planes, and what are called skew lines. Okay, so parallel lines are something you've probably seen before, but they are two coplanar lines that do not intersect. Okay, those two lines will never touch, and we use arrows to indicate that those lines are parallel. So for instance, if we look here and we use the two up and down lines, as we've talked about before, to indicate parallel lines. So here we can say that line AB is parallel to line CD. Okay? And in a similar sense here, we have parallel planes. Parallel planes are simply planes that do not intersect. Okay? And when we talk about planes, we would just say the word plane and then the name, in this case J or K. So we could say that plane J is parallel to plane K. And our last term here is what are called skew lines. Okay, and skew lines are non-coplanar lines. Okay, so they are non-coplanar. Sorry for the mishap. That do not intersect. Okay, so two lines that are non-coplanar, they sit on different planes, and they also do not intersect. So an example of this would be, say, line PS, okay, over on the bottom left, and line VR. Okay, that's one example. Another example would be TW and UQ. I remember to put lines over top of each of those. And our final example that I'll give you here is PT and QR. Okay, those are three examples of lines that sit on different planes and also do not intersect. So I'm going to let you complete these examples. See if you can figure them out. I'll give you a couple seconds to do that. And then I'm just going to have all of them filled in when you come back so that you can check your answers. Alright, hopefully these are the answers that you got for examples 1 and 2. One thing I will point out is when I asked in 1B to give parallel planes, and again in 2C to name parallel planes, I just wrote out the 3 letters. Remember, we can also name a plane by 3 letters that sit on that plane. So I just shortened it up a little bit just so that you have a little bit more room to work with and just to kind of speed up the process. So hopefully those match. If you need to, you can pause this and check your answers and see if you got them right. So we're going to transition here to a concept we're going to use constantly throughout this unit, and that's the idea of a transversal. And a transversal is a line that intersects 2 or more lines. So in this picture we have lines L, M, and T, and line T is the one that's intersecting both line L and line M. So we can say that line T is going to be our transversal in this example. And what that does is it creates 4 different angle pairs that we're going to use constantly. And there's going to be a lot more information forthcoming about these angle pairs, but I want to go through them with you just so you can see them each individually. So the first one are corresponding angles. So corresponding angles are angles that are on the same side of the transversal in the same position in their groups. So if we look up here in our picture here, we've got this group of angles here, and we've got this group of angles here. So our corresponding angles are the ones that are in the same position in their group of 4. So for instance, our set here would be, our first set would be angle 1 and angle 5, because they are both in the top left of their respective groups. And as you see there, I filled in the other 3 pairs. We've got angles 2 and 6 in the top right corner, angles 3 and 7 in the bottom right corner, and angles 4 and 8 on the bottom left corner. Okay, so we're dealing with one angle from each group in each of these angle pairs. So for our alternate interior angles, we're once again going to take one from the top and one from the bottom grouping. Okay, and they're going to be inside of our 2 lines, okay, inside of lines L and M, and they're going to be alternating or flipping over the transversal. When we say alternate, it means to flip. So one example of that would be angles 4 and angle 6. Okay, they flip over the transversal, and one is from each group. The other example would be angle 3 and angle 5. Now, the same thing goes for our alternate exterior angles. Okay, they're the ones that are outside of lines L and M, and they also flip over our transversal. So one example of this would be angle 1 and angle 7, and another set would be angle 2 and angle 8. Now, the last one are consecutive interior angles. So once again, we have inside of our lines L and M, only they're not going to alternate over the transversal. They're going to be on the same side of the transversal. Could also call them same side interior. I'll write that in just so we remember that. We can call them same side interior as well. Okay? And an example of this would be angle 3 and angle 6. And another example would be angles 4 and 5. Okay, so make sure you have those jotted down. And once again, I want to make sure that we're all clear here that our interior would be this space here, inside in red, and our exterior would be all the space outside of this in blue. Okay, so just picture that. One way to picture it is if you picture drawing in between lines L and M, thinking of it as a house, between those walls would be inside the house, the interior, and outside the walls would be the exterior. Just something to think of as you go through this. So I've got two examples here. I'm going to do one with you, and then I'm going to leave the second one for you to do on your own. Okay, so given this picture, we've got angles 1 and 8. So 1 is in the top left grouping of the left group, and 8 is the bottom right. They're both outside of P and Q, so those would be alternate exterior. And I abbreviate ALT, EXT angles because, like I've said, mathematicians are lazy people. Okay? And if you'd like to work through these alone, before I go over them, hit pause now, and then when you come back, they will be all filled in for you. So as you can see, 2 and 3 are what I call same side interior or consecutive interior, your choice, and I abbreviate INT for interior. There is no abbreviation for corresponding, so 5 and 7 are in the bottom left corner. Those would be corresponding. Letter D, 2 and 7 would be alternate interior angles. They're between those two lines being cut by the transversal. Angles 1 and 3 are once again corresponding. And then angles 6 and 7 are same side interior. Now, I've left you with problem 2 for you to try on your own. One thing to note there, you've got 4 lines coming through, so you've got 2 sets of lines being cut by 2 different transversals. Be sure to note what's written right below that picture, that angles have to be broken by the same transversal to be an angle pair. So there will be some in there where you won't have a relationship between them. Okay, so make sure you take a look at number 2, and we're going to go over it quickly in class tomorrow when you guys come in. Have a great night. Make sure to email me with any questions.